So today we're going to be talking about Simcenter durability, the module within Simcenter environment and NX. So the agenda is going to be, we're going to do a quick overview of the GUI in Simcenter. We'll do a quick intro to fatigue analysis. We'll walk through the model and the FEM. We'll go through the static analysis setup. Then we'll do the fatigue analysis setup. And finally, we'll post-process the results after we're done. Okay, so what is durability within NX? The durability module in NX enables you to do fatigue analysis within the Simcenter environment. So there's 3 different event types that you can do within this durability module. The first one is static, and that's what we're going to be doing today. We're not going to touch the other 2, but the other 2 are transient and then random analysis. So really one of the big selling points for durability within Simcenter is the relationship between the FEM and simulation to the part or the master CAD file. And so what this allows you to do is to go back and make a quick modification to the CAD once the analysis has been run. So let's say you did your fatigue analysis and you realize that something, let's say a wall thickness needs to be thickened. You can simply go back into the model with one click, go back, change the thickness, move back into the Simcenter environment, and hit update and rerun your model. Takes maybe 30 seconds to a minute, as opposed to other pre-post software where you would need to go back to the CAD, update the model, re-export the model, re-import it into your finite element program, go ahead and remesh everything, set up all your loads, boundary conditions, rerun it. So it saves a huge amount of time, and that's really one of the best features of Simcenter and why it's one of my favorites to use. Okay, so quick Simcenter overview. This should look somewhat familiar to you if you've ever used NX. The first thing that you'll need to do when you want to get into the Simcenter environment is go to the application tab here at the top and click pre-post. This will bring you straight into the Simcenter environment, and that's where you can start doing all of your analysis. Okay, so once you do that, it'll bring you into the environment, and as you probably know, when you change environments, all of the tools at the top and on the left will change. So what you're looking at here is the FEM file, and I'll kind of talk about the file structure in a bit. As you can see at the top, we have our meshing, our connections, all of our properties. So everything changes based on what environment you're in. And then on the left here is the simulation navigator. This is where you'll see our different files. When we're in the sim file, you'll see the sim at the top, the FEM, the idealized part, which we'll talk about, and then under that will be the model. As well, this will change based on what file you're in. And this is just the sim file simulation, which is where all of your loads and battery conditions will be. Okay, so the way that this is set up is a bit different from most pre and post softwares. I think from any pre and post software, you have 4 different files. You have your part file, your .part, which is your CAD file, which everyone's probably familiar with. Your idealized part, which I'll talk about in a minute, your FEM part, and then your sim part. So CAD part, everyone I'm sure is familiar with. The idealized part is an associative copy of the part file, and this is only used with the FEM. So what it does is it takes an associative copy of your CAD part and allows you to make modifications to it without modifying the original CAD geometry. So this is really important if you maybe are working in Team Center, or you want to obviously remain keep the original CAD file intact. Maybe you are working in a environment where you have a bunch of people working on the parts at the same time. So it's really great for making modifications and simplifications without changing the original model. Next is the FEM file or .fem. So this is where all of your mesh data, your elements, physical properties, material properties, all of those sorts of things are held. And then finally, the .sim file, your simulation file. So this is where your loads, constraints, boundary conditions, all of those sorts of things are, as well as where you'll define your solver-specific data. You'll set up your different solutions. This kind of shows you what that looks like. So over here on the left, you can see this is our master CAD part. This feeds into our idealized part, which in this case, they did a mid-surfacing. The idealized part is then fed into the FEM, which is where all of your, again, your elements, nodes, properties, all of that goes into. And then finally, your simulation part, which is where your loads and boundary conditions and things like contact will be. When you're in the Simcenter environment, you'll notice here at the bottom, this may be closed, but there's a tab called Simulation File View. This is what I use to navigate between those 4 different parts. So at the bottom, this is the CAD part. Next is the idealized part, the FEM, and then the sim. And all you have to do is double click to change between those files. You can also do it up here in the Simulation Navigator. This will take you to each different file and change the environments and the tools that you're wanting to use. So let's say you're in the sim file and you wanted to create an element. You're going to get lost trying to find elements because those tools will not be available to you unless you open the FEM. Hopefully that makes sense. And when you're getting ready to create a simulation, the first thing you'll do is click New FEM and Sim. And this over here will pop up, and you'll see here at the top, it'll create 2 files for you, the FEM and the sim. It's associated to the master part, and it actually gives you the option to use or not to use the idealized part. I suggest always using it, doesn't hurt. Okay, so the supported elements in durability are kind of your basic elements, your 1Ds, which are your beams, bars, rods. 2D, you have your trias, your quads, and 3D, you have your tets, your hexes, and your pyramid elements. Okay, so a quick intro into fatigue analysis. So fatigue failure is the tendency of a material to fracture after repeated cyclical stress, typically significantly below the strength of the material. So the way that we define the cyclical loading over time is called a loading spectrum. So the component can be loaded continuously in a fully reversed cyclical pattern with a constant amplitude and a 0 mean stress, which would be this graph up here, into positive tension, into negative compression, constant amplitude, and going about the 0 point, which means the 0 mean stress. It can also be loaded with varying amplitudes and a non-zero mean stress, so it can be offset into the tension region or into the compression region, and it can also be a completely random number of cycles and amplitudes and mean stress and all of that. So Miner's rule is a cumulative damage equation. This is used to calculate damage due to cyclical loading. As you can see here, this is the equation. Really what it boils down to is this damage fraction down here, lowercase ni over uppercase ni. And this is the number of cycles at stress I over the number of cycles to failure at stress I. So really what we're doing here is we're adding up these different bends, and once you sum these bends, if it equals 1 or greater, it's said that failure has occurred. So for the fatigue life criteria, these are the different fatigue life criteria that are offered in the durability module. It really boils down to two different things: high cycle fatigue and low cycle fatigue. High cycle fatigue is more than 10 to the fifth cycles, and low cycle fatigue is less than 10 to the fifth cycles. And it also is kind of branched off into strain-based and stress-based fatigue evaluation. Okay, so next thing we're going to do is go into the model and FEM overview. So go ahead and hop out of here, go into NX. Okay, so this is probably familiar to everybody. This is the NX modeling environment. Today we're going to be working on this tube fitting flange sort of deal here. Close out that. So the first thing that we're going to do is we're going to go to the application tab here at the top, click pre-post, and this is going to bring us into the Simcenter environment. So as you can see, I already have these set up, so we're going to go ahead and just use what we have here. So this is the idealized part. I didn't make any modifications to it, but this is it here. Next, we're going to go into the FEM, and so we'll walk through the FEM real quick. So in the FEM, you can see I have the entire thing meshed, as well as a RBE here on the front, which is connected to the cut face. We also have this top section here, which in the simulation we're not actually going to be using. We're just going to be using the elbow down here, and therefore these RBEs and beams that you see in these holes here, we're not going to be using. So the material that we're using for this model is aluminum 2014. And these are TET10 elements. Okay, so go ahead and go into the simulation file. And again, as I said, you can see we're only using the lower section. So I'm going to go ahead and hide those points as well as those mesh controls. Okay. So first thing we'll do is walk through the static solution, which is solution 1 here. So for constraints, have an X and Y constraint on this face here, and then a Z constraint on this lower face here, just something quick and easy. As for the load, we have a force on the center of this RBE, and it's 100 pounds in the negative Z, or the downwards direction. I'll go ahead and look at the results real quick, just to give you guys an idea. This is obviously exaggerated deformation. You see we have some stress, as you'd expect here and here, as well as on the inside. Okay, so next thing we're going to do is we're going to go and create a durability simulation. So I already have one set up, but we'll go ahead and create one using all of the parameters that I had used previously. So first thing you're going to do is click New Durability Simulation. We'll go ahead and call it Durability 2. And you see it created this new solution down here. So we're going to right click, New Event, and again, you can do static, transient, and random, but today we're just going to be doing static. And we'll go ahead and go through these 4 different parameters here. But before that, if you have multiple solutions already run, you'll select which solution that you're going to use. So in this case, we're going to use the only one that we ran, which is the solution 1, or it's solution 101 in this case. You have excitation type. We're going to be using pattern. You can use result path, which if you set up multiple subcases, it'll run through the result path. And then finally, there's function where you can define your own excitation. We're just going to use pattern. So under strength, this is where you're just going to set up your stress criterion, and you're going to get out your margin of safety and your safety factor. So this is what this is basically setting up here. So we're going to turn on strength, safety factor, and margin of safety to get those sorts of outputs. And we're using a factor of safety of 1.2. Next, we'll go to fatigue. So for fatigue, you define the number of occurrences, the fatigue life criterion. So in this case, we're using stress life, doing high cycle fatigue. We're going to go ahead and turn on event damage and event life. That way we'll get those outputs when we run this. And then to define how you're calculating your fatigue safety factor, all of these different inputs here. And then finally, we'll turn these two on as well, fatigue safety factor and fatigue or failure index to get those outputs as well. For solve options, didn't really change anything here, but you can select to only output certain elements, change default temperature, override material, nonlinear results. Depends on the situation, you may need to use it. And then finally, axis search. So axis search is defining the way that it is looking for the element face stress and the damage. And just to let you know, it only uses free faces to find the stress. It doesn't do anything through the thickness. So in this case, we're going to use element face. There's also nodal, biaxial, and we're going to be looking at the principal axes with a search resolution of 10 degrees from that. Okay, so that's for the setup. Then we'll right click on the event that we just created, create a new excitation. And again, it's going to ask you for the subcase that you want to use. We only have one subcase, so we're going to use that one. And you can set it to a half unit cycle or a full unit cycle. So in this case, we're going to use the full unit cycle. You can scale and you can offset. So this would be your mean offset here. But we're just going to leave it at scale of 1 and a mean offset of 0. Hit OK. And then we would run this here. So I already have it run. So we'll go ahead and open this. And before we do that, I'm going to head back to the PowerPoint and show you guys some post-processing stuff. So these are the different outputs that you'll get. And Siemens was kind enough to provide us with this table here, which tells us what the output means and when failure occurs. So for the strength safety factor and the margin of safety, those are pretty explanatory, self-explanatory. A strength safety factor less than 1, failure will occur, and a margin of safety of less than 0, failure will occur. For the fatigue safety factor, if that's less than 1, failure is said to occur. The fatigue failure index, if it's greater than 1, failures occurred. Fatigue damage, which this is like the minors rule that we talked about, if that's greater than 1, failure is said to occur. And then fatigue life, if that's less than 1, failure has occurred. And in that link that Andrea posted in the chat, it actually has this table and a bunch of actually really great information about it. Okay, go ahead and head back to NX. Okay, so we'll just click through these real quick to get an idea. I'm not going to change the scale, but you would want to change the scale to show that, you know, based on those criteria, if it's greater than 1, less than 1, whatever output you're looking at. But you can see here, looking at fatigue life. Next is the fatigue damage. So you see we're getting damage within here, which you kind of expect. Our fatigue safety factor. So you can see the safety factor is low where it's dark blue. Our strength safety factor is all good. And then our margin of safety and our fatigue failure index. So these are the different outputs that you get. Depending on what your criteria are, those will change, but this is how you look at it, and these are the outputs that you'll get. And so finally, some takeaways. So I kind of talked about this at the beginning, but the connection between the FEM and the CAD, let's say that we went through that and we saw that we were having a fatigue failure. You could go back and thicken the wall and rerun it very quickly, whereas it would take quite a bit of time to do that otherwise. Simcenter provides a user-friendly way to analyze and visualize the effect that the cyclical loading will have on the part. So instead of doing it, by hand, this actually shows you where and how the cyclical loading is creating damage to the component that you're analyzing. And there are a bunch more functions and capabilities within the durability module that we did not talk about, being transient and random events, as well as different parameters that you can change within the setup to fine-tune the model. And finally, we also will be having, I believe, a CES coming up where we're going to talk about the durability wizard. So it's just a quick way, just like the stress wizard, to set up a durability event without having to change all the different parameters, and it'll actually create the solution and the event type for you. So go ahead and keep a lookout for that.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.